Okay, so now what we're going to look at is called trigonomic notation of complex numbers. And you'll notice this is very, very, very similar to polar form. Okay, so if we have this point, a plus bi, so we've gone over a and up b. We can also talk about its absolute value, how far it is from the origin, and the angle that it makes with the x-axis. And just like we've talked about with polar form, we know that the absolute value, this r, is equal to the square root of a squared plus b squared. We know this forms a right triangle, so we know cosine of theta is a over r, which means if you want to find r, you can just do r. If you want to find a is equal to r cosine of theta. And sine of theta is equal to b over r, so b is equal to r sine of theta. So a plus bi, here's our a, we can rewrite this as r cosine of theta plus I, we put the I out in front, but b is r sine of theta. Now these are going to be the exact same r's, so we can actually pull this out and say r cosine of theta plus I sine of theta, and those are the same thetas. So instead of always writing cosine plus I sine, we abbreviate this as r, and then we put a cis to mean cosine plus I sine, and then we just put the theta. So, and now another thing to remember is that theta is going to be equal to tangent inverse of y over x, and you'll then use reference angles if you need to make sure you're in the right quadrant. So I always like to start by thinking, okay, where is this point? If we go over 4 and up 3, we're in the first quadrant. So the first thing we're going to do, we want to convert this to trig notation. We're going to find our r. So this would be the square root of 4 squared plus 3 squared, which would be 16 plus 9, so we have the square root of 25, which is 5. So our r is 5, and then our theta, we want to take tangent inverse of 3/4, which isn't on our unit circle, so we will have to use our calculator. So I put this in degrees, so we're going to do tangent inverse of 3/4, and we see that that is 36.9 degrees. And that is in the first quadrant, so that's the angle we want. Okay, so we would write this, so this is our r and our theta, we would write this as 5 cis of 36.9 degrees. Okay, we're going to do another one. So we have -3 minus I. So first we're going to think about that this is in the fourth quadrant. Okay. So next we're going to find our r. So this will be the square root of -3 squared plus -1 squared, which is the square root of 10. So our r will be square root of 10. Now to find our theta, we'll first do theta of tangent inverse of -1 over -3. And you could reduce that, but you don't have to, it doesn't matter. Now this is going to give us 18 degrees. Now we know 18 degrees would be up here. So let's actually, what was that, 18.4. But we want to be down here, so we want the reference angle, that's 18.4. So that'll be 180 plus 18.4. So that'll be 198.4. Okay, so we would write this as square root of 10 cis of 198.4 degrees. Okay, now we're going to go the other way, which again is a little easier, just like it was for polar. We know for here that a is equal to r cosine of theta, and b is equal to r sine of theta. So our a here would be 3 cosine of 150 degrees, which from our unit circle, if we go to 150, we see cosine is negative square root of 3 over 2. So our a here would be negative 3 square root of 3 over 2. And our b will be 3 sine of 150. Sine of 150 is 1/2, so we'd have 3 times 1/2, or 3/2. So we could write this as negative 3 square root of 3 over 2 plus 3/2 I. So this is our a and our b. Okay, and we can do the same thing here. We have square root of 10 CIS of 7 pi over 4. So our a is going to be square root of 10 times cosine of 7 pi over 4, which we can use our unit circle. 7 pi over 4. Cosine is square root of 2 over 2. Now, square root of 10 times square root of 2 would be square root of 20 over 2, and square root of 20 is 2 square root of 5. So this would just be square root of 5. And then b is going to be square root of 10 sine of 7 pi over 4, which is negative square root of 2 over 2. So we'll have negative square root of 10 times square root of 2 over 2, and this will give us negative square root of 5. So here we would write this as square root of 5 minus square root of 5i. Okay, so that's how we can convert between kind of standard notation, a plus bi, and our trig notation, which you can think of as polar form for complex numbers.